Okay, so hello everybody and welcome to the latest webinar from Labster. It's about my Labster experience. I'm just going to chat for a couple of minutes by way of introduction and allow any of our other attendees to sign up because I know that can take a minute or two. So far we're looking at about 30 of our audience of potentially 100 people joining up. So a big hello to everybody today. My name's Helen Gadigard and joining me from Labster today are my colleagues Laura Worpsha and Maria Homan. And Maria is running the operation of this webinar from Copenhagen in Denmark. So she's going to be behind the scenes. We're not going to see her, but she's certainly going to be helping us a lot and making sure the technology is working. So Laura and I are both educational specialists with Labster, and we'll be facilitating the conversation today. And today we're connecting you with a couple of really inspiring professors who found great success when utilising Labster in their teaching. And in this webinar, we're just making some time and space to be able to hear their stories from opposite sides of the Atlantic. So in a minute, Kambiz and Sabine will introduce themselves to you and tell us exactly where they are connecting from right now. So to those of you who are joining the webinar and are already Labster users, we're hoping that you'll be able to use this experience to tell us or reflect on your own practice and compare it to what you're going to hear from Kambiz and Sabine. And maybe if you've got something that you want to chip into the conversation, please do that. Put your comment in the question box and Maria can feed that to us. And if you're joining the webinar today and you haven't used Labster before, then a very warm welcome to you. I hope you're going to hear lots that's inspiring, and please let us know if you've got questions as well. So we will get a response to everyone either in the webinar or with a follow-up email afterwards if we run out of time. Some of our audience have pre-submitted questions and we're going to take 10 minutes at the end to address as many of them as possible. So if you submit a question and we don't have time to get back to you today, we will be coming back with an email. Please don't feel that you've not been heard. So we'll start this webinar with Kambiz and Sabine giving an introduction to themselves. And then we'll move on to talk through a list of open questions that hopefully will have Kambiz and Sabine tell us everything you could want to know about their experience. We've got about 6 discussion points and I'm going to keep this moving by spending roughly 5 minutes on each of those. And at the end of approximately half an hour then, there will be time for us to come to you and answer the questions that have been posted. Last of all, I just want to let you all know that we're recording this webinar and we'll email all of you a link to it so that you can listen into any particular points again or share with colleagues if you wish. So I hope most of us now, a few more have logged in, are sitting comfortably and we're all joined up, and I'd like to get the webinar started by first of all saying hello and big warm welcome and many thanks to Kambiz and Sabine for joining us today. So Sabine, could I firstly ask you to introduce yourself to our webinar guests? Thank you.
Yeah, so hi Helen, Kambiz, everyone. So my name is Sabine Matallana-Surget. I'm a lecturer at the University of Stirling in Scotland, in UK. I'm lecturing in many different topics. It goes from chemistry to environmental microbiology, ecology, advanced molecular technique, proteomics. I teach in first year, in second year, in fourth year of a bachelor degree. I also supervise master students as well as I have 2 PhD students in my lab. In terms of students number, I'm quite variable from one module to another. It goes from 20, 30 students to up to 220 students. I've been using Labster the past 2 years already. In 2 modules I'm coordinating at the University of Stirling, so one in first year and the other one in fourth year. So the one I'm using in first year, as it's written in the slide, is practical skills and laboratory skills, SCU1LS, with 220 students. And the other module where I'm using Labster is called Advanced Molecular Technique. And this module has less students, so 30 students, because it's final year. And for each of those 2 modules, I've been using 3 simulations so far. Well, 2 simulations for the final year module. So in practical skills, I've been using the lab safety simulation and 2 chemistry-based simulation, acid-base and ionic and covalent bonds. And for the final year, I've been using the gene regulation and protein synthesis. And this third year, I'm using those 2 simulation. And I'll be using a new one that, well, in my module, the experimental design. I really look forward to use this one. And so that's me so far. Hope I'll keep it short because I know we have many things to talk about also. So that's my introduction.
Thanks so much, Sabine. So Sabine is in Stirling and I'm in Glasgow. That map that we saw previously, we're only about an hour apart from each other. But we're now going to jump many hours away to Kambiz. So hi, Kambiz, would you like to introduce yourself to us and tell us where you're from as well?
So I get the red slide. I'm very excited about that. I like red. So my name is Kambiz Hamadani. I'm assistant professor of chemistry and biochemistry at California State University, San Marcos. It's a medium-sized university. And in my department, I'm primarily teaching biochemistry and GOB chemistry courses. So I used Labster first for a general biochemistry course that's offered primarily to non-biochemistry majors, so chemistry and biology majors. And I decided to use Labster in that course because there wasn't already a lab associated with it. It was a lecture-only course. And I felt that it would help to allow the students to solidify a little bit more their knowledge and content appreciation for the topics we were talking about in lecture. And so I used some of these, the enzyme kinetics module, basically standard biochemistry virtual labs that Labster offers for that purpose. And my history with Labster actually goes back quite a ways. I started to get involved with Labster when I was a postdoc at UC Berkeley before I got hired in my tenure track position. And I was involved in some early proposal writing, and I've kind of seen the progression of Labster's capabilities and offerings. And I'm very excited by the trajectory that Labster's taken.
So
in my second class that I used Labster's virtual labs for, this was the following year, I received some funding to implement a combination of virtual labs and take-home labs and redesign a GOB, General Organic and Biochemistry course for non-science majors, primarily nursing and kinesiology students. And there, the main idea was to essentially try and relieve a little bit the resource burden of offering lots and lots of lab sections to non-science majors, which our department was somewhat burdened with, trying to fit all the different sections that we have of the science major science lab classes. So by taking some of the virtual labs that Labster offers and replacing some of the hands-on labs that the students were doing and to some extent taking up space and time from the rest of the students, we were able to save approximately 33% of the laboratory space time and push some of those experiments to the home front. So that was a value for my university and for the similar resource burdened campuses.
That's great, Kambiz, and there's a lot of points that you were raising there that we're going to be coming back to in our questions, so we'll just be reiterating some of that message. But the take home is really that you're both incredibly busy people with a diverse spread of teaching there, lots of problems that you're facing in teaching, and we're not even touching on your research, so I know that. I know how busy you both are. Kambiz, my question would be, and I hope we do get time to come back to this, I'm seeing that huge list of simulations that you've got on your GOB chemistry course, and I'm just wondering how you fit all of those into a class and exactly how you build that into the course structure. But I'm really hoping we get time to come back to that detail.
Sure.
So we're going to keep moving. That's great. We're right on time, 10 minutes for introductions. So the first question then to kind of open up this discussion was, what was your path to using Labster? Now, Kambiz, I know that you mentioned something about that already. You've got a bit of a longer history. But Sabine, first of all, do you maybe want to tell us how or why did you end up coming to Labster and using the products in your classes?
Yeah, so I started as a lecturer at the University of Stirling in 2015, and 1 year after that, I was contacted by Kathy McLab, who is the director of the information services, sorry, in Stirling. And so she wanted someone to pilot the use of Labster at the University of Stirling and include that in different modules. And because I was hired to direct a new degree and design new modules, so it was also quite easy for me to include new tools in a new modules in a new degree. And I was really keen. So of course, before agreeing on anything, I just did test the test, like the different simulations, and I really enjoyed those. So for me, I instinctively have some ideas on how to include those simulations in my module, and this is what I did. So this is basically, I didn't know anything about Labster when I moved to Scotland, but this is how I've been approached and how I've heard about Labster as actually someone from the director from the information services who wanted to pilot the study. So I used Labster 2 years ago. I started using Labster 2 years ago, and since that time, I'm still using Labster, and some of the lecturers in Stirling are actually using Labster now.
Nice. So I don't think that's completely unfamiliar, maybe with some of our listeners, that there's been a decision made by somebody else, one of your colleagues, and you were in a really nice position that it was a new course. They were looking for something innovative to make the course new and shiny, and that all fitted into place perfectly. Now, Kambiz, I know you've got a bit of a longer, more complicated history. Do you want to talk us through that?
Sure. So my introduction to Labster was just basically finding them on the internet somewhere around 2012, 2013. And I was at the time working as a postdoc at UC Berkeley. I went to undergrad at UC Berkeley, so I did the biochemistry labs and went through all those classes. And I felt like it would be a valuable tool for the students. And so I pitched the idea of having one of the, at the time, biochemistry professors that was teaching the lab incorporate some of these virtual labs into the course that I had taken and which many others after me had taken. And so we put together a little proposal to bring Labster to Berkeley and start, incorporating some of those virtual labs into the biochemistry lab courses as a sort of preparatory tool. Unfortunately, that proposal was never funded, but it got me introduced to the Labster folks, and when I moved to my current position, I continued the interest and was keeping tabs on Labster's progress, and eventually had the opportunity to use their virtual labs in a general biochemistry course that did not have any lab component, and so Labster seemed to me to be a very nice and well-suited tool. So I applied for a course redesign grant from our chancellor's office here. The California State University system is 23 different campuses, and the chancellor's office invests quite a good bit in course redesign efforts. And one of those branches of course redesign involves the use of virtual labs for various science courses. So I got some of that funding and redesigned my general biochemistry course to incorporate those a small subset of virtual labs, and things went well, and I continued to explore the various means that Labster could be implemented in different types of courses. And so the following year, I also tested Labster's benefits in a different course, which already had a lab, but it was with a very different purpose, trying to reduce the amount of actual face-to-face lab time that students and instructors meet in a lab space to reduce the resource costs. And both of those experiences were very, very interesting for me, and I learned a great deal, and also honed my skills and perception of where the sweet spot is for using Labster labs.
which is probably what everybody wants to know, Kambiz. You've managed to reduce the resource spending in your wet labs and increase your use of the simulated labs. So you've definitely hit the sweet spot there somehow. Hopefully we'll unpick that in the interview today as well.
Yeah.
So let's move on to the next question then. Thank you, both of you, for telling us how you came to Labster. Now, this is a really big question. And again, we're just going to try and spend about 5 minutes on it. But I'm aware that many people who are listening in here are going to be feeling it can't be smooth sailing all the way. There must be some disadvantages to using Labster. And we want this to be really open and let you tell us if there was anything that was a stone in your path to using the simulations. Now, we're sure that there are many, many advantages that you've found. Kambiz, you've already told us some of those, and Sabine as well. But briefly, guys, if you want to tell us a little bit about the main advantages and disadvantages you found in using Labster. Sabine, let's start with you again.
Okay. So I'll be short and brief. And so I think there are definitely 4 main big, huge advantages for the students. And then I'll mention 2 advantages for the teachers and lecturers. So the first one, I think it's great to have scenarios, because I think it's good when you have real practicals to have kind of a recipe, a protocol where you follow step 1, step 2, step 3. But sometimes it's good to zoom out and understand why you're doing this experiment. Why is it important to understand this concept in chemistry or doing this practical in the lab? So the first advantage, scenario. It puts into perspective, in context, what you're doing this technique. Second is to visualize things that are sometimes difficult to understand for students. For instance, chemistry, sometimes it's difficult for them to understand chemical bonds or things that are not really, they're not visualizing things. So they visualize plants, animals, biology, but they don't really understand chemistry sometimes. So it's great to have simulation. It works much more efficiently, a simulation, than drawing on the whiteboard or even sometimes a book. So I think it's great to have simulation. So this is the second point. Third point is mistakes. So they can do mistakes and learn from their mistake. And this is good also because most of the time, if they have assessment, they're stressed because they have the assessment, or in a real lab, you're not really allowed to have mistakes because consequences could be huge. And so this is why I think I like also especially the lab safety one, because 1 hour lecture on lab safety can be really boring. But when you're using the lab safety simulation, I've done all the simulation. I really tested all the simulations. So I really wanted to know what the students could do in a lab and what kind of mistake they could do. So I did tick all the wrong boxes and everything to see the consequences. So they really understand the consequences of their own mistakes. And I think this is really key also, to do mistakes and learn from your mistake. And you cannot do this in real lab. You can do this in a simulation. That's completely fine. Also, they can assess their own individual knowledge, which is great because in a real practical, most of the time they work as a pair of students. So they sometimes rely on the other students, dominant students, or someone who is very good students. So they never really are able to assess their own knowledge in terms of practical skills as well. So because they work as a group, because we are not able to provide so many consumables or equipment sometimes. So it's great because they can assess their own knowledge whenever they can in their home. They're not really stressed, and this is their own knowledge. Then fourth one is really the great revision tool. So it's a great revision tool for the students before a final exam. They can practice, they can revise, they can assess again their knowledge before an assessment, an online test or a final exam, or sometimes also it's helpful before specific coursework, that you know that those simulations are key for the specific coursework during the semester. So those are really 4 main points for the students. And the 2 last ones that I wanted to say for the teachers, for the lecturers, I think it's great to assess the progress of your students, because not only because of the final score of your quiz, but also to see whether students are engaging in your module, they're taking the simulations on time because you set deadlines, and also how long they took to take the test. Is that did they do a lot of pause and resume, or did they really engage and did everything on time, and how long they took, etc. And also it saves a lot of time for the students, for the teachers, to set mock exams or some kind of tutorials for the students to practice with some knowledge. And also because you can use those simulations to assess one specific lecture, for instance, one on chemistry, on bonds or ionic covalent bonds. You know that students are struggling a little bit with this, so you can assess or give quizzes through the simulations just on one specific lecture, and it's not the whole content of the semester. And most of the time we're providing quizzes on the whole semester and not one specific one that you know already that students are struggling with. So those are personally, I think the pros, the advantages. And regarding the disadvantage, I'll try to be short. I think there is no disadvantage, and I'm not paid by Labster. It's just that I think it's not a disadvantage really of Labster. It's just the way teacher or lecturers could use it that wouldn't be so efficient. So I do personally think that lecturers should test all the simulations before including those simulations in their class, and also maybe depends on what the purpose, but the way you use it sometimes is not very efficient. So or like lecturer would use it wouldn't be that efficient. So I think it's carefully thinking on how you want to use Labster in your module. It will work efficiently. So this is the disadvantage, and it has nothing to do with Labster. It's more how your teaching skills, or like the way you want to teach or use Labster in your module. So that's the only really problem that I would say.
Thanks, Sabine. There was so much in there, and I do remember hearing as well when I was a lecturer, somebody saying to me, somebody with lots of experience, saying that any teaching tool really will work as long as it has the enthusiasm and the motivation of a great teacher behind it. It's completely how we implement them. So that's a real insight. Thank you. So Kambiz, I know we're spending a bit longer on this question. Don't feel rushed, because we will go through the other ones more quickly. This is a really big question, but your advantages and disadvantages.
So I think everything that Sabine mentioned is absolutely true. I want to reiterate the importance of molecular visualizations that are enabled by Labster, and in particular the dynamic aspects of those visualizations, which you sometimes can get from videos and things that are available online, but you don't really get in a textbook. And it's hard for each individual instructor to design their own dynamic molecular visualizations of dynamic processes. So I'm thinking mostly protein structure, function, and dynamics. So those are important tools. I think I do want to reiterate the importance of allowing students to make lots and lots of mistakes, doing the labs over and over again for repeated practice. This is something that we can't do in a physical face-to-face lab. We're limited in space, and in time. The number of times students are allowed to repeat a procedure is one of, I think, the most important limiting elements of the way that labs are currently run, face-to-face labs are currently run. So I think that that's a great value that Labster brings. And also, as an extension of that, because the virtual lab tools are not limited in terms of the time that's allowed for students to complete them, students can take a lot more time to go through in great detail, what's involved in the various steps. When in a physical face-to-face lab, normally students are rushing through the procedures because there's really not that much time for them to get through all of that stuff and fully comprehend it. So those are some of the key things that I think the virtual labs offer, amongst many others. I would guess I would also say, as far as disadvantages, I think that there is a very large diversity of ways that you can implement the Labster labs, and I can speak from experience in saying it's very easy to overload students, for instance, with too many of the virtual labs. I did that and suffered the consequences. So it's important to know how much students can handle, and also making sure that the content of the virtual labs is well aligned to the objectives of the course. So The current versions of the Labster virtual labs have their learning outcomes already pre-packaged. There is, I can say, some very important updates that will soon be coming out that will give, I think, instructors more freedom to choose and play with the content of the labs. But as they are now, you have to really be very careful in selecting which virtual labs you use, how you implement them, and to what extent you allow students the freedom to explore things outside of the scope of the content that you're presenting in lecture, which will take away to some extent from the time that they spend on the course material. That's not to say that the experiences that they get from doing those other activities or covering those additional topics is a disadvantage. I think actually it's a great advantage, but some students may not necessarily appreciate it if it doesn't have a direct impact on their exam grades or their course grade. So this is something which has to be considered to some extent if you're really trying to achieve perfect alignment with the course.
So I think we're going to come on to this in a wee bit, actually, is how you can align it with your course, as you were mentioning there, Kambiz, whether it becomes part of your student's summative assessment or not, and if that's something that is easy to fit into your course, and how that engages students. And I just want to pick up on something really exciting that Kambiz was making reference to there, about the flexibility that's potentially, will be coming soon at some point with the simulations. Kambiz is referring to something that we're calling our chemistry builder lab just now, which is something in the pipeline for development, but eventually allowing instructors, to manipulate the labs to build your own experiments. It's super exciting. I don't know enough about it to talk more about it just now, but I'm imagining you'll be having a conversation in another webinar quite soon about that at Kambiz when we're a bit further down the road with that. So really exciting to see those developments. But let's stay on task just now and move on to the next question, which will maybe move through a little bit more quickly. Oh, this is another big $1 million question though. So the learning outcomes, how do you make sure that these are being met by your students? We have learning outcomes listed for every single simulation, and the idea is that these learning outcomes should be in topics and in language that is translatable to your own courses as well. So there should be a pretty good match between our learning outcomes and your learning outcomes if this is a simulation that's going to work for your students. Now, Labster simulations have got quizzes built all the way through them, usually in the region of about 20 multiple choice questions in each simulation. And that's really to make sure that the student or the instructor is seeing that they're achieving those Labster learning outcomes in the simulation. How do you use those quiz scores? And do you feel this is enough for you to feel that your students have achieved these learning outcomes, or is there more that you need to do, or do you do something completely different? Sabine, back to you first of all.
Well, for me, there is a very good match between the learning outcomes are suggested by Labster and one that I have for my own modules. I personally don't use Labster for the assessment. So for me, it's more like a formative assessment more than a summative assessment. But nonetheless, it means that I'm still looking at the score, when they're taking the tests, the simulations, and how long they took to actually take the test itself. So it gives me the progress, the success through the scores, but also the progress and the engagement of my students. So, and during the whole semester, because for some half modules, you would have one coursework, one final exam, and most of the students would be, okay, I'm not really working until, last minute, 2 weeks before the exam. And I know that some coursework would require some work, and so this is why they will have to do those simulations before taking, or maybe before having a specific coursework. So it's just a great tool just to make sure that students are creating a routine, are working continuously. And also, if you're just using Labster because you want to make sure that your students are working continuously, probably they won't engage because they will understand that you're just doing this just to make them work and that's it. But if they really understand that those innovative tools are helping them to visualize things that they're struggling with, or that those tools will definitely help them to be successful in one coursework, because maybe they will understand the concept of doing your own experimental design, for instance, or they will remind you the main steps in the protein synthesis, or they will understand how important it is. So this definitely students will engage. So it's just a question on explaining clearly why you're using those simulations. And definitely it shouldn't be a reason like, oh, I'm using those simulations because I definitely don't have time, to cover all those topics in my lecture, so I will use those simulations. So if you really give good explanations on why you're using those simulations, I think students are not stupid. They really understand that you're using that to help them out for their grades, for their final exam, and also to enjoy as much as possible topics that they don't necessarily enjoy to start with. And also, I just wanted to emphasize one last thing, is that there are huge differences between using Labster in first year and in final year, not because they are younger or older, it's just because in first year, when they enter university, sometimes they have compulsory modules. So for instance, the one I'm coordinating, a huge class of 220 students, in this class, I have students enrolled in 7 different degrees, going from sports science to cell biology, ecology, conservation. So not all the students have decided to work on chemistry, but this is compulsory because you need to have some basic knowledge on chemistry for all those different degrees. And in final year, you will have students in degrees that are matched directly with the topic of your module, molecular biology, with students enrolled in a degree in cell biology, so they are much more confident. But then in first year, that you would think that they wouldn't necessarily engage so much in a module related to chemistry, because sometimes their degree doesn't really have chemistry in the future. But because they're struggling, because they didn't really pick this module because they really like chemistry, they are just still using it because they can practice and visualize things they are really struggling with sometimes. So I would say that it's really different. Depending on the year, first year, second year, third year, fourth year, it really depends on how you use it. If it's more like a revision tool in fourth year because they're already confident, or is just to make them gain confidence because they are struggling with some modules they are not maybe familiar, or they don't really necessarily enjoying like the topic because it's not the one that they picked to start with. So I think it's just good to have a good think about why you're using Labster, how you're using it, which simulations you think are the most suitable for your particular module, and also how you want to approach Labster, and explain to the student why you're using Labster, what is the goal exactly. So I think it's good communication of the lecture to the students is really key and important.
I think you've done an amazing job if you've managed to convince your students, Sabine, of the value of formative assessment. And if they engage with it for the purpose that it's there, it's assessment for learning rather than assessment of their learning. And if you've managed to get a class of 220 to engage with that for their own means and their own better end, then that's fantastic. But Kambiz, I think you've got quite a different use just now of the quizzes and simulations.
I just wanted to reiterate a point that Sabine made again about the first year versus senior year students, and the difference in the way that you implement these kinds of tools. In the GOB course that I redesigned, one of the main things, and I think Sabine mentioned this, was in pushing some of the lab experiments to the home front, and also some of the activities that they were doing to the virtual front. You separate lab partners, and so there's a great deal of independence that you're really enforcing on the students, and having them become more independent of their lab partners. And this is something which the first year students have a much more difficult time with. I found this out, and I think that that's a very important thing to mention to anyone that's going to be implementing Labster in the context of, if you're actually going to be thinking about replacing or introducing these tools to first-year lab classes. Seniors have much more greater comfort and ease with doing experiments on their own, and I think that lends itself to using the virtual labs a bit more. On the topic of learning outcomes, so Labster has its learning outcomes for the virtual labs, but I actually, although I do alignment matrices for my course learning outcomes versus each of the modules that Labster has, and I try and pick the virtual labs in a way which maximizes, the alignment. I don't so much assess the students using the quizzes. Of course, I award them some degree of points for completing the Labster labs, and try and ensure that they're going to be paying attention and reviewing the theory sections, because honestly, that's where all of the most important elements of the Labster labs are. It's in getting them to review all of that content in the virtual lab. But my main assessments are aligned to either American Chemical Society or other external certifying bodies that have very specific guidelines on what should be included in general biochemistry course or GOB course. And I tried to limit to the greatest extent possible, especially for the assessments that I was doing, the degree to which my personal picking and choosing of learning objectives, or switching between Labster's learning outcomes and the ones that I originally intended for the students to learn, and which ACS and other certifying bodies have kind of emphasized in terms of what they see as important. I didn't want to change any of that. I wanted to see, as is, how do the Labster labs reinforce the learning outcomes that we already know and love and emphasize. And so I chose the virtual labs based on which ones were maximally aligned, and there were definitely some that weren't maximally aligned, and I found that those were generally the least effective or difficult to get the students to engage with, whereas the ones that really were most aligned or best aligned to the learning outcomes that the course was already focused on, the students got the most out of, and they improved on those learning outcomes the most when they performed the virtual labs. So I think it's absolutely crucial that you pay great attention to the learning outcomes that you've got, the learning outcomes that the Labster virtual labs are reinforcing in their modules. Do alignment matrices for the activities and your course. And I think that this is also another reason why the new tool that I mentioned, which gives instructors much more flexibility in terms of exactly what parts of the virtual labs they are going to implement and use, will be of great value. So I'm very excited about that tool, if you can't tell.
You'll be one of the first to use it, I'm sure, Kambiz. I think it was interesting that you've both pulled up that same point about the difference between your more junior and more senior learners, and about their comfort levels about working in social groups or working independently. And I just wonder as well then if Labster's a tool that can be used to encourage that more independent learning, and if that's another advantage to encouraging students to work on their own like that. There's a little less security from having a peer with them, but they're not being observed by a teacher. They've got space to make those wee errors.
Making mistakes, again, it goes back to allowing them to make mistakes, and not having it be, nothing's going to explode, nothing's going to break, and that is extremely important, especially for the earlier stages of their introduction to science lab work. And I think that's a great value, and absolutely.
Great. Okay, we've got 3 more questions to do in about 10 minutes. So the next one that I wanted to ask you about was, how did you make your class engage with Labster? if you were giving, Kambiz have said that you were giving some points for their completion, but Sabine, you have said that you used it formatively. Now, Labster,
yeah, I don't give any points.
Okay, so an engagement has to happen because you want your students to get everything from the experience, but we know as well that you're paying for these simulations and you're not going to get your licenses paid for again by your management teams if they're looking at poor engagement. So engagement's really important from lots of different angles. How did you manage to keep good engagement?
Well, as I said, so like I explained earlier on, I think it's just great if you, like, each lecturer is explaining clearly what is the goal of the simulations, why those specific one, why do we think that those specific simulations will help them in the understanding of the whole module. And as long as they understand that it's just another tool, also when they read the module outlines, if they see like a big diversity of tools that we're using to help them understand like a topic, they would usually enjoy that very much. If they have lectures, practical tutorials, seminars, workshop, Labster and other tools, they really enjoy that because they have a wide diversity. They have just practical skills or just lectures, they find it quite boring because they're like, students get bored easily. So they just, and they're right. I think it's great to provide many tools just to keep them entertained, but also redundancy in a module is key as well. It's fine if you just present 2 hours of chemistry on chemical bonds and then they go home and then maybe 1 week or 2 weeks time, they will practice with the same concept but differently, in a different way, in different angles that you've been teaching. So I think it's good to provide diversity. And as long as you explain this to students, explaining we are offering you wide diversity of tools for you to make sure that you got it and you enjoyed it. You enjoyed chemistry. For me, it's the best victory ever. If I have students not enjoying one topic and at the end of the semester, they, oh my God, I understood, enjoyed it, I feel confident, because confidence has a lot of things to do with enjoyment and success. So I think they will be they will do very well, and then they will be successful. So what I do is I usually communicate very well, very clearly at the introductory lecture. Why am I using Labster? It's a new tool, so I will show them a little video so they will understand what it is all about, that they have a quiz, but it's not assessed or no pressure. But in first year, I set clear, firm deadlines. So because I know exactly why I'm using those tools. So I'm actually giving deadlines for each particular simulation. For the fourth year, I'm more flexible in terms of deadlines. I give 3 simulations and I just give 1 general deadlines, as if by this time you should have completed the 3 simulations. So I'm a bit more flexible for the deadlines. But I give deadlines anyway, because I know that those different simulations will be helpful for 1 online test or 1 other coursework, something that will be assessed later on in the semester. So this is how they feel really engaged. And with Labster is they know that they could have questions also at the final exam, and that those tools will help them. So this is why they're engaged. They understand that those tools are here to help them. And that's enough, because in 220 students, I had 80% of the students taking those tests. So even though they were not assessed, so I think, yeah, students understand why you're doing.
That kind of speaks for itself, those kind of numbers with first year chemistry. And Kambiz, how did you manage to get that level of engagement? And actually maybe here as well, can you tell us really briefly, okay, something I would really want to know is that sweet spot you were talking about. You've had a large list of simulations there in your course.
Yes.
In your course, what was your kind of optimum number? And it looked like a large number. How did you keep them engaged in all those simulations?
So for the GOB course, where I had a large number of simulations, I did the students were doing about 11 or 12 face-to-face labs, each one, I think, 2 hours, 15 minutes apiece. And so I basically counted the amount of face-to-face hours in the traditional version of the lab, picked the labs that were perhaps the least necessary to do in an actual physical face-to-face lab space, and either replaced or moved some of those labs to the home front, or replaced them with virtual labs that could be done using the Labster tools. So there was, and I kept track of how much time the virtual labs were supposed to take. And so there wasn't any extra actual amount of time that the students had to, there wasn't any additional time burden on the students in terms of replacing the virtual labs with the face-to-face labs. In terms of engagement, certainly making sure that they carry out the labs in the correct order, that's important, as Sabine mentioned. But what I also found in the general biochemistry class, and to a large extent, I think discussions with Sabine influenced me on this one, but giving the students some degree of freedom to also have a say in which labs they carry out is very engaging. And this is something that the virtual labs actually do give you. You don't have to have a fixed lab and have all the students do just that one lab. If there's a range of different options with different labs that perhaps have different degrees of overlap with the content of your course. So actually this semester, for the first time, thanks to Sabine, I'm implementing a sort of choose your own adventure version of the Labster lab portion of the course, where I've picked I've tagged each of the virtual labs with an alignment, a degree of alignment number with the content of the course, and so the students get some degree of points for completing each of the virtual labs but weighted basically by how much that particular virtual lab aligns with the course content. And this gives the students a great deal of flexibility to choose content that maybe aligns with the research that they're doing in their independent studies thesis projects. And I think that's a great valuable, it's a great deal of value there also for the student to be able to explore things that interest them, but which also have some degree of overlap with the course content. I just basically, they have to do more for, to get those points in my course. So they pay for pursuing their own interests, not unlike, to some extent, what we have to do as researchers ourselves.
I think they find, sorry, Kambiz, finish up, yeah.
So I think that engagement comes in to some extent from giving students more flexibility and a little more say in the topics that they cover. I found also in the earlier implementations of Labster in my general biochemistry course that students in general did enjoy the class. There was a very small but significant decrease in the degree to which students thought that biochemistry was boring, quote unquote, when I did that assessment. So I guess there is a significant increase in engagement, but I favor Sabine's model in allowing students in a structured way to have a little bit more say in the content that they're exposed to.
Yeah, I think that from both of you, I think you must be building incredibly dynamic courses, and I love that you're giving responsibility there is being handed to the students for them to take ownership of their learning. So there's less of that divide between the professor and the learner. You're telling them what to do. They're choosing what to do. They're responsible for their own education. And I think that's super, super exciting for them and allows that personalisation that we really want to achieve in education as well. Everybody working at the level that they need to be at and the level that's pushing them a little. I think you're both such inspiring teachers that, frankly, I think if you were teaching in a shed, your class would all be super happy and learning lots from you. We've got about just 2 minutes. I'm going to skip the next question. We did have a question that was asking how Labster impacted on engaging students in your course overall. And we're just going to hop past that question, actually, because we've talked a lot about student engagement. I just want to really briefly, while I've got you both here, because you're both such forward-thinking and exciting professors, ask you what you feel about the future of VR, virtual reality, immersive headsets in science education, because obviously this is a big product that Labster has launched recently with online biology degrees. So we're super excited about it. I know that you're not using that just now. Is this somewhere you see yourselves going? How is it going to affect teaching?
Well, I would love to use the Google headsets, and in first year, especially for visualization and help the students to visualize chemistry or things that are a little bit abstract to them, and especially in first year. The only thing would be being very well organized when you have like huge classes. Just maybe organizing this by having goggles in one dedicated room where we could just organize different groups and would have maybe 40 students, 30 students attending to this room and just doing the simulations. So it's just a question again of organization, of sitting and thinking quietly, having a good thought about everything and trying to organize everything very well. But I think that would be amazing to include that in the teaching, and I hope maybe Stirling will be piloting this again in different modules. I'd love that, and I hope it would be in my modules definitely. So I'm really excited about this, and I've tried this just once. It was 2 years ago, and I was really like a kid, and I wish I would have had this in my as a student at university, just turning the head and having the DNA molecules and all the translation proteins, and I found it really exciting. So I would love to use that in the future, really.
Oh, well, Sabine, if you've not seen it for 2 years, a lot has happened since then.
Really? Oh my God, I need to see you
soon. I'll bring my headset. Let's do that. And Kambiz, do you think this is the future?
Yeah, I am very, very excited about the future of VR in higher education and in science lab technologies, in particular with Labster. I think that there's a huge untapped resource there. And I'm actually doing some work on specific niche within that world focused on mixed reality. And trying to bring the tactile sensory experience that students have when they perform an actual hands-on face-to-face lab into the virtual realm, so that students can still get so that you're not limited in terms of the degree of immersiveness of the virtual labs by the game controller that's used to interact with that virtual realm. And I think that that's in my view, one of the main criticisms that many faculty that I've spoken to, and rightly so, this really is not a completely authentic experience for the students when they're not really manipulating samples and volumes and reagents in the same way that they would in a face-to-face lab. And I think that once we've resolved that aspect of the inauthenticity of the virtual labs, there's going to be a huge tidal wave of new applications and advantages for students. And so I'm very much focused on delivering on that and working with Labster to do so, hopefully. So we'll see.
Certainly a really exciting time to be working in this field, and it's going to be the fruits of labours such as yours, Kambiz, researching this all the time, that's going to keep pushing this forward. So I think assessment, making sure that what you do has an impact. We'll all keep working together and watching each other's spaces and watch us progress over the next few years. It's going to be amazing when everything comes together. So Maria, who's in the background, can we find our slide that has the questions that were pre-submitted? I'm aware that we have only got about 5 minutes left. So I suspect we're not going to get into any questions that may have been posted live. So apologies to anybody. We will definitely be following up with emails. And the best that we're going to do here is just to fire through some of these questions that came in. The first one there was about how does one properly instruct on the use of a microscope in a virtual world? So it's exactly the point that you were just pulling up, Kambiz, about how real is that experience. I think from my perspective, and I did use the bacterial isolation simulation when I was teaching, So it wasn't using the microscope, but it was doing a practical skill. And the students in the virtual environment were able at least to practice that process. So my students were handling Petri dishes and Bunsen burners in the simulation. They didn't have the feel of it, but they did have the experience of learning all the steps in that process, so that when they came into the lab, they were quite familiar with the process, recognised all the equipment, and knew how to handle it and what they were doing. So I'm hoping that that's going to answer the question that came in there from North Carolina. Have either of you used the microscopy simulation? I haven't for teaching.
I haven't.
I very briefly looked at it, but I do confocal microscopy in my lab, and I can tell you firsthand that there's a lot of ways to mess up a confocal microscope. And to have the students do that virtually would be a great benefit.
So this next, sorry,
so we do have, Kambiz, we do have the confocal microscopy one. I think you should take a look at it, because it does, I like about it is the fact that you can toggle and actually extend how, like, the detection limits and the sensitivity of the microscope, which when you work with instrumentations like that, they're very sensitive, and if you go beyond the limited detection, you'll ruin the detectors. So it's a really great one to play.
You fried the APDs, huh?
Yeah, yeah, pretty much.
Nice.
Another big,
go ahead, Helen.
Big question that came up there was a question about how Labster can reduce the number of experimental animals that are used in research. And that's a really, really key question to a lot of teachers and researchers. So first of all, the simulations aren't aimed for research use at all. It's not going to reduce the use of experimental animals for research, but the use of animals for teaching can be massively reduced. And we've got 3 or 4 simulations specifically using animal models in the simulations. Again, students aren't getting the hands-on experience, but it's arguable whether they really need that hands-on experience. And that's the whole ethos driving the programme to reduce the number of animals that are used in science teaching. So if we have a simulation, we have one on invertebrate models, we have one on embryology and development of animals there. Laura, off the top of my head, there are a couple of others.
I know that I believe the experimental design one actually uses, I know there's one that uses mice, and
what's the axolotl? I can't remember the name of the simulation.
No, that's
I think it's the respiration, cellular respiration, or the
the cellular respiration I believe uses the mice, and
there's tissue regeneration.
Yes, and those as well. There's a couple of institutions that partner with us that do specifically look at the cost and the benefit of using Labster simulations versus actual animal testing, because those are students who are at a lower level, and they would have to actually become certified in handling the animals. So I know that there's a couple of institutions that partner with us that have done studies on that. So, yeah.
And I'm just going to skip now to the last question there. And big apologies, people, that we've not had time to come to your questions, but we've been so engaged in our chat with Kambiz and Sabine. Last question there was how much you were involved in creating the scenarios in Labster for your students. And I can pretty much answer that question that neither Kambiz or Sabine were involved in building the scenarios. In the history of the company, we did have academic partners who would co-build simulations with us. And that's not happening now with Labster on the same scale that it was at all, because we're really focusing on building up the gaps that have been in our catalogue and working on that on a really prodigious scale, so that we're not looking for such direct partnerships with academics anymore. But what we are doing, as we've mentioned earlier, is opening the doors to allow you to be creating your own labs, which is going to happen with the Chemistry Builder Lab and other features that we're bringing into the simulations about allowing you to edit the questions that are in the simulations as well, to really allow you to add more meaning and value to those, and to personalise them for your students and make sure they're all getting the most out of it. I've got a minute to go, so I'm going to wrap up and say thank you all so much for joining in the audience. I hope you found it as engaging and as inspiring as our professors are, and as engaging and as inspiring as Labster is. Do have a look at the website there to see any upcoming webinars. And we will be following all of this up with an email with a recording of this webinar and answering questions by email as well that we've not had time to. So Sabine and Kambiz, thank you so much for your time. I've loved speaking to you as much as I always do. Laura, my backup, thank you so much for being there in case my broadband collapsed and for chipping in there at the end. And Maria in the background, we can't see you, but you've done a star job as well. Can't wait to see you facilitating the next webinar. So thank you all very much, and we'll be in touch again soon. Goodbye.
Thank you.
Thank you.
Bye. Thanks.
Bye.